I'm going to talk about one of the research divisions, the Hurricane Research Division. It's on, I believe. So our vision is to advance understanding and prediction of tropical cyclones, track intensity and structure change, and their impacts utilizing observations, modeling, theory, and Erica? It's on. But you're... So we've been doing this type of research in NOAA for over 60 years. The National Hurricane Research Project started as a 3-year program in 1956, where we started using aircraft to observe tropical cyclones, particularly in the Atlantic. And so we are sort of the next, the reality today of that initial concept. So our mission, as I said, is to understand and predict tropical cyclones. How we get there is we use 3 tools to hold up this stool: observations, modeling, and analysis systems, or data assimilation, if you want to look at it that way. We use these tools. We look at observing strategies. How can we better estimate or characterize the tropical cyclone structure, intensity, and track? We use those observations through the modeling and the data assimilation system to evaluate the model performance, the forecast guidance. This is a critical aspect of how we do our research. We're linking all these 3 pieces together to get to where we want to be in understanding and predicting. Also, as John mentioned, we're starting to go into the facets paradigm, the forecasting a continuum of environmental threats, to evaluate the products that come out from these model predictions, and the performance of the model directly affects how we communicate that risk. And so that's an aspect of our research as well. 2 big efforts are driving most of this. The first is what we call the NOAA Intensity Forecast Experiment. It was begun here in 2005 as a partnership with our Environmental Modeling Center at the Weather Service, the National Hurricane Center, the Aircraft Operations Center, and NESDIS, to combine our effort. Not one of us could do all the tasks that we had to do, so we wanted to combine our resources and our efforts to address 3 key strategies: collecting observations over the tropical cyclone life cycle. We wanted to be able to gather observations to drive the forecasts. And you have to remember, 2005, HWRF was coming online in 2007, the Hurricane Weather Research and Forecasting System. And so that was a lot of the driver in the first aspect, addressing situation awareness. What do we know? And how do we predict it? The second part was to develop measurement technologies. This is our technological aspect, where we're trying to improve the way we observe and characterize what's happening in the tropical cyclone environment. This is where we develop new observing technologies, new observing strategies that you'll hear about. The third is really the research aspect, improving the understanding of the processes important in intensity change. And so we had this developed in 2005. Rob Rogers, who you hear about, was the author of the paper. We have an update also. The second driver was the Hurricane Forecast Improvement Program. John mentioned hurricane supplementals. A lot of our efforts are driven by disasters. The Hurricane Forecast Improvement Program came about after 2004 and 2005 hurricane seasons, when the administrator of NOAA, Admiral Lautenbacher, said, what did we do right and what did we do wrong? He put together he tasked the Science Advisory Board to put together a working group to give us recommendations. They came with 34 recommendations. From those 34 recommendations, we put together a plan to address them, and that became the Hurricane Forecast Improvement Program. It's a unified approach to guide and accelerate forecast improvements. And it's recently been updated thanks to the Weather Act that Admiral Gallaudet mentioned. We put together a plan, updating it, The original plan was a 10-year plan. In '09 it started. This is the new upgrade that came with addressing Section 104 of the Weather Act of 2017 that went up to Congress. And the goals there are improved prediction of rapid intensification and track, improved forecast and communication of storm hazards, and then relative to Paul's comments, incorporate risk communication research to create more effective products. So those are the two big drivers that have been pushing us forward in the last 10 years. So talk about advancements. We look at the observation side. I mentioned IFEX. It started in '05. We've had a number of NSF and NASA partnerships that have dovetailed with it. We have this capacity to observe, and we bring in our partners to help us address certain issues. RainX, we were addressing how the rain bands affect and how the eye wall replacement cycle, which you hear about, works. Predict was focused on genesis or initiation of tropical cyclones. And so we use this to also look at our technological developments. The step frequency microwave radiometer is our rule of thumb for measuring surface winds. IRAP is a profiler that looks below the aircraft. Real-time Doppler radar. Global Hawk, we evaluated the Global Hawk with our NASA partners. The G4 tail Doppler radar. Unmanned aerial systems, the Coyote was the first one. Doppler wind LiDAR, real-time G4 tail Doppler radar now is getting into the models. And the wide swath radar altimeter, which is giving us the two-dimensional wave field. And now we're starting to bring all this stuff into the visualization tools that the Weather Service uses in AWIPS too. On the forecasting prediction side, we've also had, through the Hurricane Forecast Improvement Project, a number of developments that have improved the hurricane modeling environment. HWRF came online in 2007. Due to our research efforts, we upgraded it to add a third nest and go to 3 kilometers and 12, 2 kilometers and 15, 1.5 kilometers and 17, and now we're starting to work under UFS, the Unified Forecast System, on the next generations. We've also had a number of statistical dynamical prediction developments from the SHIPS model, the decay SHIPS, rapid intensity index, tropical cyclone genesis index. So there's a lot of work going on. And at the same time, there's all this science looking at aspects and characterizing the tropical cyclone from eye wall replacement cycles, rapid intensification genesis, surveillance to get a map of the environment that's driving the track of the storm. Asymmetries in the storm. We've gone from an axisymmetric view to an asymmetric view. Vortex dynamics, total kinetic energy and diffusion in the boundary layer that drives a lot of the model physics. The vortex and shear. Most storms are developing in shear, and you'll hear some about that. This is a big area of interest, and particularly in rapid intensification, air-sea interaction, and now impacts. So a lot of this development is driven by those two major programs. So HRD personnel, we have a staff of 52, 24 are research scientists, 28 are research support. We usually have 4 to 6 interns every year between Holling scholars, NERDO, and just interns from universities participating in our research activities. We have, like I said, the 3 big parts of the stool. Observing, it takes about 41% of our staff activity. Data assimilation and observing system simulation is 36%, and 23% is in modeling. We also have a lot of collaborations. PHOD, the Physical Oceanography Division here, is now a very active collaborator with us through the glider program. We're starting to do ocean data assimilation now with the Environmental Modeling Center. And they are working on observing system simulation experiments as well with us. NOAA, the Hurricane Forecast Improvement Program, National Hurricane Center, big collaborator, both under facets and under AWIPS 2. They interact with us in observing, modeling, and data assimilation. The Aircraft Operations Center, the NOAA Hurricane Hunters, mainly they're our big partner in all the observing. National Centers for Environmental Prediction, the Unified Forecast System, some AI, artificial intelligence and machine learning activities are going to be driven through that interaction. NOAA satellites, we work with NESDIS, particularly on our data assimilation and observing system simulation experiments. The NOAA Observing System Council through the Quantitative Observing System Assessment Program works with us. And then NCAR, we're working closely with NCAR on observations and some on modeling through the Developmental Testbed Center under HFIT. Our other partners and stakeholders throughout NOAA, we have partners and stakeholders that work with us closely. We have outside other federal agencies. We have numerous universities that interact with us. We have industry, people who are working with us either on instrument development or evaluation of our observing system analysis. And then internationally, we work within the WMO. We have big partnerships with the India Ministry of Earth Science and the India Meteorological Department, and then with CMA, the Chinese Meteorological Agency, through this Shanghai Typhoon Institute. HRD by the numbers, we have 40 publications this year. This is 19, and then I give you the last 5 years since the last review. Number of transitions, as you can see, that's been increasing dramatically as we've been working more and more closely with our partners at the Environmental Modeling Center and the Weather Service. And then the number of funded proposals. John mentioned how much proposal-driven research we have. Most of these proposals that are funded are through NOAA programs under the Office of Weather and Air Quality. HRD by the numbers on products. We have about 15,000 or so registered users of our products. When we talk about products, a lot of it is our data, flight level data, which is from the aircraft flight level, our radar data, dropson, step frequency data, and our model data. We also have on our website something we call the frequently asked questions. This is also mirrored on the AOML website. It's probably one of the most popular web links out there. We maintain that together with our partners at the Hurricane Center, and it's been translated into 3 or 4 different languages. You can get access to all of our data sets via our web. Our budget by the numbers. 2019, our budget was roughly $7 million, of which about $4 million or so was base, and the rest was proposals. This is our budget back to when I took over as director in 2003. You can see that we had a bump up in 2008. That was HFIP on the OER side. And since then, it's been relatively flat. Proposals have jumped up. A lot of these are hurricane supplemental activity, as well as the beginning of the Office of Weather and Air Quality support through OAR. We're going to talk a little bit about major research areas. I'm going to let the folks that are here to talk to you present those areas. We have 3 major themes: characterize, understand, and predict processes important to tropical cyclone prediction and their impacts. Drs. Zawislak, Dunyan, and Rogers will speak to those. Another major research area is our optimization of use of observations to improve forecast guidance. Dr. Kukerel and Sippel will present that major research theme. And then the third one is advanced hurricane forecast guidance. Dr. Gopalakrishnan and Alaka will present those. We have posters related to those major themes that you will see tomorrow. One is on rapid intensity change, which is our #1 research topic. And then another one will be on our challenges and opportunities for making improved observations in tropical cyclones. We also have emerging research areas. Impacts is a #1 area, and John has already brought up our forecasting a continuum of economic threats. This is the facets umbrella. Shirley Murillo, my deputy, will talk a little bit about that facets as well as our partnerships and transitioning to operations, which is one of our key efforts. Other emerging research areas, you'll hear about 2 of them in posters, one on new tropical cyclone observing technologies, where we'll cover unmanned systems as well as aircraft-borne systems. And then the unified forecast system and the Hurricane Forecast Improvement Project have what they call, under that new plan, one of their strategies is called the Hurricane Analysis and Forecast System. So you'll see that in that poster. Other areas of emerging technology, emerging areas of research is in data mining and in cloud computing. As you can imagine, with the amount of observations and model data that we produce, there's a lot of synergies that can be generated by these data sets. And as you'll see in our challenges, one of those big challenges is how do we get those 2 data sets merged together to improve our ability to understand and predict tropical cyclones. Another area of emerging research that's coming through the Unified Forecast System is coupled data assimilation. The Unified Forecast System is an Earth modeling framework, so the ocean is going to be a key player. I think that with our partnerships here with the Physical Oceanography Division and their strength in observing, and they're developing, looking at data assimilation in the ocean and our partnerships with the National Weather Service, this is a big area, I think, that we can really make a big push into the research on that developing area. Our challenges, big one, balancing long-term basic research with short-term research to operational applications. This is a major effort. We are a research laboratory, but we have very key partners in the operational side that rely on us. I think John Cortinas mentioned our fact that we fly on the planes. We do the quality control. I like to say we're victims of our own success, that we are doing a task that is operationally important to provide that data to improve the forecast models. We don't get any extra money for doing that. And so the challenge we have here is how to work with our partners to either increase their base or our base so that we can carry this task out. We have research scientists. I mean, I flew in Dorian, you know, when it's all hands, everybody flies when you have a situation where you want to get that observations. And so this is a big area of challenge. Consistent, stable year-over-year base. You saw our salary, our base budget's flat. John's right. We shouldn't expect that to increase. But the challenge is we have these hurricane supplementals. We get a shot of money, we inject it. We have to balance that shot of money. How do we accelerate things? And then what happens if they shut off in 2 or 3 years? Talent and recruiting and retention. Obviously, this problem affects that problem. Finding not only the good talent, but how do you maintain that effort as you move from supplemental to non-supplemental? Observing costs, I just mentioned that. Flight hours, we rely on OMAO and AOC for their base funded flight hours. Sometimes we can get support through supplemental to augment those. Expendables and personnel, those are big challenges for us because we don't have a budget for that. We have to take that out of our base or figure out how to balance that. High performance computing access. As you heard, we're very much involved in modeling and data assimilation and observing system analysis. That takes a tremendous amount of high performance computing. The Hurricane Supplemental is augmenting our research computing very nicely, but when the supplemental ends, how that works out, the high performance computing balance has got to be something we pay attention to and we support. And finally, data management. As I mentioned, we have tremendous amounts of observations and model data that we have to manage. The best way to do the science is through collaboration. We have to get the data sets on a server where people can access it, our partners can access it and do other things than we would even think about. So this is a big area of effort that I think the whole lab has to worry about, not just the Hurricane Research Division. And with that, I'll say thank you and pass it on to Dr. Zawislak.